What if we detonated all nuclear bombs at once? In our previous videos, we explored what would happen if every single person on Earth simultaneously pressed the trigger on every single firearm in existence, or if every single car on the road were to explode. But what would happen if every nuke in the world went off at once? Well, today we're going to find out. We made a huge pile from all 15,000 nuclear bombs and pulled the trigger. Some of them are intercontinental ballistic missiles. Some are submarine-launched ballistic missiles. Some are artillery shells and some are air-dropped devices. The exact yield of each device varies wildly, but collectively they could cause massive damage and casualties over a wide area. In fact, current estimates suggest that the total nuclear arsenal could cause devastation over an area the size of the contiguous United States. However, the actual amount of land suffering the worst effects, that is where nuclear winter might occur, would be much smaller than this. For instance, the total nuclear arsenals of Russia and the US alone could destroy every building within 300 miles of the detonation point. The debris and dust from these destroyed buildings would then spread around the world, blocking sunlight and killing crops. This would lead to a nuclear winter in areas far away from the initial blasts. So let's see how this global pile of 15,000 nuclear bombs works, and afterwards, we'll even make a bigger one. The destructive power of nuclear weapons comes from two sources, the blast and the radiation. The blast is similar to a massive explosion with devastating consequences within 30 miles of the detonation point. Thermal radiation is released in all directions from the fireball, causing third-degree burns on everything it touches. This includes severe sunburn and possible eye damage to anyone who sees it. The light and heat are so intense that it can ignite buildings and other flammable objects. This is followed by a shockwave that literally blows everything apart. These effects kill most people and destroy most buildings within 30 miles of the blast. Further away, the thermal radiation isn't strong enough to ignite objects, but it still causes serious burns. The shockwave also gradually weakens and can still blow down walls and other unmovable objects. Blast waves can travel hundreds of miles, and the pressure can still be strong enough to break windows and doors. These effects can kill people and damage buildings hundreds of miles from the detonation point. Radiation is released in all directions from the start of the explosion. When the thermal radiation reaches something, it causes the electrons in atoms to absorb energy and jump into higher orbits. When the electron drops back down to its original orbit, the energy is released as ionizing radiation, which can damage DNA and cells. The amount of radiation someone receives depends on their distance from the explosion and the duration of their exposure. People who are too close to the blast receive a lethal dose almost immediately. Those further away may survive, but suffer radiation sickness and possible cancer. Radiation can also spread to the rest of the world via the cloud of debris thrown into the atmosphere. This is known as fallout, and it can kill people days, months, or even years after the explosion. 15,000 nuclear bombs at once. To keep things simple, let's assume all the nukes have the same explosive power. Let's also assume that we've removed everyone and everything from the blast radius. That way we can only focus on the effects of the explosions themselves. In reality, this wouldn't be possible, because people tend to stick around until they have to move away. So many lives would be lost in the first few minutes from the thermal radiation and blast wave. So in our perfect world where nobody dies and nothing moves, we take 15,000 nukes and put them in a giant pile. Then we hit the detonator switch. Within nanoseconds, the entire landscape is vaporized. A fireball the size of Texas engulfs everything. The shockwave generated by the explosions spreads outwards, destroying every building within 300 miles. Millions of square miles of land is devastated. Everything in the blast radius is either obliterated or vaporized. Then the radiation starts to spread. Whatever did not get blown away by the blast wave is now irradiated by millions of nuclear bombs going off at once. At this point, the sky is filled with nuclear fire. As the radiation spreads throughout the atmosphere, radioactive particles float high into the sky, creating a thick radioactive cloud. It looks like a massive mushroom cloud, but instead of being just a few miles high, it reaches tens of kilometers up through the atmosphere. As the fireball expands, it creates a massive fireball mushroom cloud that towers 100 kilometers up into the sky. This is 20 times the height of Mount Pinatubo, the world's tallest mushroom cloud ever created by a volcanic eruption. Hot ash and debris are thrown into the atmosphere at speeds of up to 175 kilometers per second. That's faster than the space shuttle. A layer of debris about 1 meter deep covers the ground within 300 miles of the explosions. Let's see what happens beyond the immediate blast radius. 300 to 1,000 miles away, the shockwave has weakened, but it's still powerful enough to level entire cities. Most of the thermal radiation is gone, but some did reach this far, causing serious burns to anyone exposed. The fallout has reached this point, killing everyone in its path. Windows and doors are blown open, roofs are peeled away from their foundations, chimneys are snapped off, and large animals are thrown dozens of meters through the air. At this point, the blast is long gone, but the fires caused by the thermal radiation continue to burn out of control. They will rage for hours before eventually being extinguished by the falling debris. Meanwhile, the sky is filled with a thick orange cloud composed of smoke, ash, and debris. It blocks out the sun, plunging the world into darkness. Temperatures plummet to below freezing, and snow begins to fall. But the radiation continues to spread. Between 1,000 and 3,000 miles away, the winds have dispersed most of the radiation, but there is still enough to kill crops and contaminate water supplies. Animals begin to sicken and die, especially those that eat contaminated grass or drink irradiated water. Humans who eat this food or drink this water develop cancers that kill them within months. The shockwave is long gone, but the explosion lit brush fires that continue to burn out of control. People in this region need to wear gas masks while outside because the air is still hot and filled with debris. The sky is dark and gloomy as the fallout continues to spread. Over 3,000 miles away, life goes on, but people in this region must wear gas masks while outside. The winds will eventually carry the fallout over this region, but thankfully, the amount is so diluted that it doesn't cause any immediate effects. In the immediate aftermath, the blast and thermal radiation kill most people within 300 miles. The shockwave destroys most buildings and infrastructure, killing more people. Those who survive the initial blast die later from radiation sickness and cancer caused by the fallout. Now the rest of the world suffers from contaminated food and water supplies, killing more people, and we haven't even made the biggest pile yet. What happens if we make an even bigger pile? To really appreciate the scale of destruction, let's go even bigger. Let's use the total nuclear arsenals of all countries. To make things easier, let's make the pile 1 mile wide and 1 mile long. Then it's tall enough to hold all 15,000 bombs. When all 15,000 bombs explode, the blast plus thermal radiation instantly kills everyone and everything within 300 miles. The thermal radiation kills everyone else who sees it, including people who are thousands of miles away. The shockwave does more damage, blowing everything away and incinerating anything left behind. However, something new is happening here. There are so many bombs exploding at once that they trigger each other. The shockwave from one bomb sets off another. The fireball from one bomb ignites another. The radiation from one bomb kills the next. It's like a chain reaction that keeps getting stronger. The explosion is so big that it punches a hole in the atmosphere. A massive plume of debris shoots hundreds of kilometers up into space. It's visible from Earth's orbit. The explosion is so bright that it can be seen from Jupiter. Fallout spreads throughout the atmosphere, reaching every corner of the planet. No place is safe. The radiation kills everyone on Earth. If there was still any life left, the fires would spread until every tree is burnt. The temperature rises dramatically, causing ice caps and glaciers to melt. Sea levels rise and flood most coastal cities. People who survived the explosion now face a new challenge, surviving the nuclear winter. The debris in the atmosphere blocks sunlight, plunging the world into darkness. Food and water become scarce, and the cold makes it impossible to grow anything. The only way to survive is to stay inside and wait for the skies to clear. But this could take years, or even decades. So what do you think? Do you think you could survive this apocalyptic scenario? Let us know your thoughts. Also, check out our video on what would happen if every single car exploded. Until then, stay safe and don't forget to subscribe.